Hi, sixth graders. Today we are looking at Chapter 1, Lesson 2, Guided Practice, which is on page 22. And we're going to do some more sample problems together before you work on the problems independently for homework. So a little bit more practice together. Write each ratio as a fraction in simplest form, then explain its meaning. So we are being told to use the fraction, not either of the other two ways to represent a ratio. So we're not using the colon, we're not using the word to. We're being given instructions to write it as a fraction in simplest form, and then to explain its meaning. So we are asked to write a fraction to represent the number of pens to pencils. So let's go ahead and look at the number of pens. We have 1, 2, 3, 4, 5, 6 pens. And then the number of pencils, 1, 2, 3, 4, 5, 6, 7, 8. So we have 6 pens to every 8 pencils. And then we are asked to write that as a fraction in simplest form. So remember, when we're writing the fraction, the first item mentioned will be our numerator, and the second item mentioned will be in our denominator. First and second categories mentioned. So this will be pens over pencils. And for every 6 pens, there are 8 pencils. So we know the greatest common factor of 6 and 8 is 2. Both of those numbers are divisible by 2. So 6 divided by 2 will give us 3. And 8 divided by 2 will give us 4. Okay, so that's our ratio as a fraction in simplest form. And then explain our meaning, its meaning. So what that tells us is that for every 3 pens, there are 4 pencils. For every 3 pens, there are 4 pencils. And that's explaining the meaning. Number 2, we are asked to find the ratio of pennies to dimes, okay? So pennies, there are 1, 2, 3 pennies, and dimes, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 dimes. So pennies to dimes, the category that is mentioned first will be in our numerator. The category that's mentioned second will be in our denominator. So pennies is in the numerator, and dimes goes in the denominator. So 3 to 9, 3 over 9, and the greatest common factor of 3 and 9 is 3. So 3 divided by 3 is 1, 9 divided by 3 is 3. So our simplified fraction is 1 to 3, and then we are asked to explain its meaning. So this means for every 1 penny, there are 3 dimes. For every 1 penny, there are 3 dimes. Okay, then let's take a look at number 3. Last month, Ed ate 9 apples, 5 bananas, 4 peaches, and 7 oranges. Find the ratio of bananas to the total number of pieces of fruit, then explain its meaning. Okay. So 9, 5, 4, and 7. Okay, so we have 25 pieces of fruit total, and this was bananas to total. Okay, so bananas to total. So there were 5 bananas, and then we just added up, there were 25 pieces of fruit total. So 5 bananas for every 25 pieces of fruit. And then when we look at 5 and 25, the greatest common factor of 5 and 25 is 5. So we can divide each of these by 5 to get 1/5. That's our answer as a fraction in simplest form. Okay, then we need to explain the meaning. So every 1 out of every 5 pieces of fruit that Ed ate was a banana. 1 out of every 5 pieces of fruit that he ate was a banana. Okay, 1 out of every 5 pieces of fruit. Add 8 was a banana. Okay, number 4. Scroll down a little bit. Divide 28 cans of soda into 2 groups so that the ratio is 3 to 4. Okay, so when we see that 3 to 4, we know this is going to be, there's 7 sections total. Okay, so 7 sections. How many in each of those 3 sections? How many cans of soda in each of those 4 sections? Okay, so 28 divided by, we know we want to have 7 different groupings total, so that we can split that up into a 3 to 4 ratio. So 28 divided by 7 equals 4. So there will be 3 groups of 4 and 4 groups of 4. Okay, so again, the way that we got that was we knew that we need to set up groups of 3 to 7 ratio. So there are going to be 7 different sections all together, and they're going to be grouped in one group of 3 and one group of 4. Okay, and then once we knew that there were going to be 7 sections, we did 28, the number of cans of pop, divided by 7. So we know that each of those sections will have 4. Okay, so let's go ahead and make that 3 to 4. We'll use a tape diagram. One that's not quite even, but that's actually pretty. It's also a little too narrow to write in, so I'll just redraw that. So 3 to 4. That's our group of 3. This is called a tape diagram or a bar diagram. And that's our group of 4. And we know that in order to have 28 cans of soda divided evenly, each of these sections will need to have 4 cans of pop. Okay, so 4 times 3 is 12 in that section. 4 times 4 is 16. And then we double check our math. If we add these together, do they add up to 28? Okay, 6 plus 2 is 8. 1 plus 1 is 2. Yes, they do add up to 28. So we will have 12 in the first group. $12 cans of pop in the first group and 16 cans of pop in the second group. Okay, so there will be 12 cans of pop in the first group and 16 cans in the second group. So 12 and 16. And then number 5 says, how can you use mental math to determine if a ratio is simplified? So if you want to see whether a ratio is simplified, you're just checking to see if the numerator and denominator or first and second number in the ratio have a GCF of 1. So if the two numbers have a GCF of 1, if the two numbers have a GCF of 1, they are simplified. Okay, if they don't have a GCF of 1, like let's say they're both even numbers, like 2 to 8, then you would divide each of those numbers by 2 and get that 1 to 4 ratio so that it is simplified. Okay, so again, this was page 22, guided practice on chapter 1, lesson 2, working with ratios. Okay, and again, we can use this specific set of directions told us to write these as fractions, but as you know from our notes, we can also write these, so here it is as a fraction, but you could also write, if your directions didn't specify, you could write this as 3, so here's the fraction, you could write it as 3 to 4, you could write it with the colon 3 to 4, or, I should say or here, you could use words 3 to 4. So those are all really great. They're acceptable ways of representing a ratio, the relationship between two categories of numbers. Thank you.